I mean, I took this test. Yeah, I took this test too. Oh, is that a picture of the day?
My mom thinks our generation has a sense of entitlement. Entitlement? Yeah, like we've had everything handed to us without appreciating the effort behind it. Wow, that seems a little harsh. She tends to get judgmental like that when she's researching my term papers.
I don't get it. I didn't hear it from the beginning.
Never mind. Okay, so I would like to see if you guys learned anything from all that demonstrationing what we just did. So there'll be a couple words here that we didn't cover, but most of them we have covered. What do we call the substance that waves?
Medium.
That was the medium. What do we call the high point of a transverse wave?
Crest.
That was our crest. The height of the wave was the amplitude. What did we transfer in a wave?
Energy.
NRG. The low point of a transverse wave was a trough. That is spelled TROUGH.
Like a trough that pays you guys.
Like a pig eats out of a trough, it's shaped the same way as the trough. Well, hey, where you know?
Wow.
What do we call the type of waves that disturbs the medium at right angles to the direction of wave flow? That was transverse. When we disturb the medium the same direction as wave flow, that was longitudinal. And if you can't spell that well, it's on the very next line down. Longitudinal. The stretched out portion of the longitudinal wave is a
Rarefaction.
and the scrunched up portion of a longitudinal wave is a compression.
Where are you going to bed? Rarefaction.
One crest plus one trough equals one wavelength. What do we call how many waves pass a point in a time period?
Frequency.
When people do the wave, what is the medium?
There are.
The people. You will find that the wave doesn't look very good if the arena is empty. Now, how many people have done the wave before? Okay, what do you do with your body?
You wave it.
You go up and down, but the wave moves to the side. So that must be a transverse wave. It is also called a mechanical wave. Because if you have to have a medium, it's a mechanical wave. So, again, with no people there, it's not going to be very exciting to watch. So it's definitely a mechanical wave.
If we're talking about sound waves, would medium be there?
Yes. Sound waves, the medium is usually air. It can be other things too, but it's usually air. Okay, number 13, we have a diagram to label. So we look at this and we say, hey, number 1 is clearly pointing toward the crest. Number 2 is pointing toward?
Amplitude.
Yes, that was the distance from the rest position down to the trough. Same thing if it was the rest position up to the crest. That is called the amplitude.
I thought the amplitude goes from the bottom to the
No, amplitude is from the rest position down to rest position up.
traveling.
Number 3, if I'm measuring from a trough to a trough, it's the same as if I measure from a crest to a crest, or if I'm measuring a trough and a crest, that's going to be one wavelength. Number 4 is pointing toward this middle line, which is the
Medium.
No, the medium is actually waving right now. So that's the rest position of the wave. Number 5 is pointing down yonder, so that is the P-R-O-U-G-H. Number 6 asked what type of wave was this? Well, if I have crests and I have troughs, it must be a transverse wave. And question number 7 says, how many waves do I have here?
4. How many wavelengths? Wavelength.
3, 4.
3 and a half.
3.75. 4. 3.75.
If we're starting here at a crest, then the next wave ends at the crest. So that's 1, and that's 2, and that's 3, and that would be 4 if I made it to there, but I didn't. So halfway between here and here would be here, so this would be 3.5, but this is halfway in between there, so yes, that would be 3.75 wavelength. Now that funny little symbol that I just drew is the Greek letter lambda, which stands for wavelength. So that's 3.75 wavelengths. That is the Greek letter lambda.
Is that what it looks like?
Well, that's the way I draw it. I don't know if that's the way it looks. Your middle name is lambda? Moving on. Number 15, because I don't like 14.
Why?
There's no 14. And there was also no letter. What letter was it on the test? There wasn't a letter. Like you went like A, B, C, D. Oh, there's no I.
Yeah, because I is bad to put on multiple choice.
I know, but.
Okay, anyway, the unit of frequency is going to be the Hertz, and that is abbreviated Hz. When I was in elementary school, the big joke was you would come to your friend and you say, "Do you want a Hertz donut?" And they would hear the word donut and get very excited and say, "Yeah!" And then you'd smack them in the arm and say, "Hertz, donut!" And you guys laugh at how corny that is, but you're going to go home and pummel somebody. So. Velocity, of course, is still in meters per second. A hertz is a wave per second, basically. And a wavelength is, again, wavelength, so that is going to be in meters. The lambda is the symbol for wavelength, but the unit for wavelength is going to be meters because it's a measurement of length. So that's all very straightforward. What do we call the pivot point of a standing wave?
The node.
Those were nodes. And what kind of interference was it with nodes? Well, which one? Constructive or destructive? Destructive, because they didn't move because something was trying to pull up while something was trying to pull down. What do we call the point of maximum displacement?
Oh, okay, I get you.
Instead of being the node, they were the antinodes. What do we call a wave with a regular repeating pattern?
Standing wave.
Those were standing waves. Super easy, right?
Yes.
What must I do to increase the amplitude of a wave?
Increase the energy.
I had to add energy. How did adding that energy affect the speed?
It didn't.
It didn't, because the speed was determined by the medium. How did adding energy affect the wavelength? It didn't, because the wavelength was influenced by the frequency. Very good. When I made the wavelength, when I made the increase in frequency, the wavelength got smaller. When I had a low frequency, I had a big wavelength. So yeah, that's the way the computer looks at lambda.
Wait, what did you say about the wavelength symbol and the unit?
That's the symbol for wavelength, but the unit for wavelength is meter. Like the symbol for velocity is v, but the unit for velocity is meters per second. So the frequency, how is the frequency affected when we change the energy?
It isn't.
It doesn't change because I determined what the frequency was. Now, in 20 and 21, there are math problems, which means we need a new, and the wave formula is found right here. It's V equals F lambda. V stands for?
Velocity.
Actually stands for speed. And F stands for
Frequency.
and lambda stands for
Wavelength.
wavelength. So again, speed is equal to frequency times wavelength. So if you know frequency, you know wavelength, you'll be able to solve these two problems very, very easily.
Don't care about direction.
Nope.
So it's skate with
So everybody got that formula written down?
Yes.
Somehow.
D equals F lambda. Really tough.
Yeah, like I just can't remember.
I give up on physics.
Yeah,
I can't.
the algebra is going to be a beast.
It's 21.
We don't have 21.
Yeah, we do. It's right there.
It's right there. There's two problems. What's wrong with you?
21.
Number 22, what do we call waves that curve around corners?
Yes.
These are called diffracted waves. We did not discuss those while we were doing the demonstration because that one's hard to show. We'll go into more detail on that tomorrow. What do we call waves that bend when changing mediums? These are called refracted waves, and again, we'll cover this in more detail at a later time.
What'd you say?
Refracted. So diffracted is bending because I'm going around something. Refracted is bending because I'm changing mediums. When I change mediums, I'm changing the speed. And so that's what's causing the refraction. But again, we'll get into more detail on that. Right now, we're just defining it.
No, waves that don't.
Waves that bounce back are called reflected waves.
Rebounding.
What do we call it when waves add to make bigger waves?
Yes.
Constructive interference. And when they partially or completely cancel out, we call that destructive interference. Yes. Well, that's because today was just an overview of stuff what we're going to be talking about in the next several weeks. So that's why there's lots of vocabulary today.
It's new vocabulary.
Only for common people.
Whoa. Whoa.
What about waves that don't have patterns? Would those be sitting waves?
No.
Shots
Yeah.
of blue fire.
That wasn't a good
I cry every time.
Number 27. We talked about number 28, but we didn't talk about 27. The type of wave that needs no medium is called an electromagnetic wave, and so the only waves that can travel in space are electromagnetic waves. So we talked last unit about radiation, and we said that heat moves in electromagnetic waves, specifically in infrared waves. But infrared and visible light and radio waves, these are all electromagnetic waves, and we'll talk about those in a couple weeks. But we did say, what do we call a wave that has to have a medium to wave in?
Mechanical.
That's a mechanical wave. And so an echo, of course, is a reflected sound wave.
See.
And then we get to number 30, and we say, hey, look, it looks like some numbers. It's going to be another problem. So I'm going to need a formula. Now, we already have the wave formula, but there's one other formula we can use with waves, because waves in a given medium travel at a constant speed. So how many constant speed formulas do we have? One. And that constant speed formula is V equals d over t, which you can use in number 30. So we have now worked through everything here except the 3 math problems. So your homework for tomorrow is doing the 3 math problems.
That's hard.
Wow, it's going to be tough, right? Here is a little gift that talked about a tsunami that happened when you guys were little babies in India. And so what happened was there was an earthquake right in this region that caused a big landslide, and so we had this huge wave that was going, most of it was going west and some of it was going east. But when we watch this thing play out, we notice that when the wave hits India and Sri Lanka, a lot of it bounces back. That would be reflection. So the poor people over here, they got hit with the first wave and then it bounced off them and came back and nailed them again. Now, the people on the west side of Sri Lanka and India thought, oh, we're perfectly safe. But no, there's diffraction where I bend around the barrier, and notice how it bends around the barrier. Now, the waves back there were not as strong as the other ones, but if you were still hanging out at the beach, it was a bad day, even if you were on the west side, because it refracted around like that. So, that's all we're going to do for today. We're going to come back and do this other stuff. Whoops, I'm going the wrong direction. The other stuff tomorrow. So that'll be it for today. So all you got to do is finish up those 3 homework problems.